Ever wondered how milk transforms into the delicious cheese we love? The process is more fascinating than you think. Cheese is a staple in kitchens worldwide, but have you ever thought about what goes into making it? From fresh milk to perfectly aged wheels, cheese production blends tradition and technology in an intricate process. Factories today use advanced techniques while preserving age-old craftsmanship to create a variety of textures and flavors. Stay tuned as we take you inside a cheese factory to reveal every step of this incredible transformation. Don't forget to like, subscribe, and share if you love cheese. Cheese, a beloved culinary delight, has been cherished for thousands of years across diverse cultures. While early cheesemaking was an artisanal craft practiced in small batches, the growing demand for cheese has led to large-scale production in modern factories. These facilities blend traditional craftsmanship with advanced technology, ensuring efficiency, consistency, and variety in cheese production. The journey of cheesemaking in factories involves multiple meticulous steps, each contributing to the final product's texture, flavor, and quality. From sourcing fresh milk to packaging the aged cheese, every stage is essential in crafting this delectable dairy product. Milk, the essential ingredient. Milk serves as the foundation of all cheese, with its composition playing a crucial role in determining the texture, flavor, and overall quality of the final product. The type of milk used greatly influences the characteristics of the cheese, as different animals produce milk with varying fat and protein content. Cheese can be made from cows, goats, or sheep's milk, or even a blend of these, each lending its unique taste and consistency. Cow's milk is the most widely used in large-scale production due to its availability and balanced fat content, making it suitable for a broad range of cheeses. Goat's milk, known for its slightly tangy and earthy flavor, is often used for soft cheeses, while sheep's milk, rich in fat and protein, is ideal for aged cheeses like pecorino and manchego. In modern cheese factories, milk is sourced directly from dairy farms and transported in large, temperature-controlled tanker trucks. These trucks are designed to maintain the milk's freshness by keeping it chilled during transportation, preventing bacterial growth and spoilage. Depending on the factory's location and milk supply chain, some facilities receive milk from multiple farms, while others operate within integrated dairy systems where cows are milked on site. Regardless of the source, maintaining milk quality from farm to factory is a top priority in industrial cheesemaking. Upon arrival at the factory, the milk undergoes rigorous quality testing to ensure it meets the highest standards for safety and consistency. These tests measure microbial safety, pH levels, fat and protein content, and overall freshness. Factories also check for contaminants such as antibiotics or harmful bacteria that could affect the cheese-making process or final product. Only milk that passes these stringent quality control measures is approved for production. Since large-scale cheesemaking requires uniformity, factories often standardize the milk by adjusting its fat and protein levels before processing. This ensures that every batch of cheese maintains a consistent taste, texture, and quality, meeting consumer expectations and industry regulations. Standardization and preparation of milk. Before cheesemaking can begin, the milk must be standardized to ensure uniform fat content, which plays a crucial role in determining the consistency, texture, and flavor of the final product. Standardization is essential in large-scale production, as it allows cheese factories to produce batches with consistent quality, meeting industry standards and consumer expectations. The fat content of milk varies naturally depending on the breed of the animal, its diet, and seasonal changes. To achieve the desired fat levels for specific cheese types, factories use a process called centrifugation, which involves spinning the milk at high speeds to separate the heavier cream from the lighter skim milk. The type of cheese being produced dictates the level of fat adjustment. Whole milk, which retains its natural fat content, is typically used for richer, more flavorful cheeses like cheddar and Gouda. In contrast, low-fat cheeses such as mozzarella and ricotta require milk that has had some or all of its cream removed. The excess cream separated during standardization is not wasted. It is often used in the production of butter, ice cream, or other dairy products. By carefully controlling the milk's fat composition, factories ensure that every batch of cheese maintains the same taste, texture, and structural integrity. Once the milk has been standardized, it undergoes pasteurization, a critical step that ensures safety and extends the shelf life of the final product. Pasteurization involves heating the milk to specific temperatures to eliminate harmful bacteria while preserving its nutritional components. The most commonly used method in factories is high-temperature short-time (HTST) pasteurization, where the milk is heated to 161 degrees Fahrenheit, 72 degrees Celsius, for 15 seconds. Some factories use ultra-pasteurization, which heats the milk to 280 degrees Fahrenheit, 138 degrees Celsius, for a few seconds, significantly increasing its shelf life. However, certain traditional and artisanal cheeses are made from raw, unpasteurized milk. To ensure safety, these raw milk cheeses must be aged for a minimum of 60 days, allowing natural bacteria to develop flavors while inhibiting harmful pathogens. By carefully standardizing and preparing the milk, cheese factories lay the foundation for high-quality, flavorful, and safe cheese production. Fermentation. The role of starter cultures. After pasteurization, the next crucial step in cheesemaking is fermentation, which involves adding beneficial bacteria known as starter cultures to the milk. These bacteria are essential for transforming lactose, the natural sugar in milk, into lactic acid. This process lowers the milk's pH, creating an acidic environment that is ideal for curd formation. Fermentation is not only necessary for coagulation, but also plays a key role in developing the cheese's texture, aroma, and flavor profile. Additionally, the presence of starter cultures prevents the growth of harmful bacteria, ensuring the cheese remains safe for consumption. The type of starter culture used depends on the variety of cheese being produced. Mesophilic bacteria, which thrive at moderate temperatures, are used for cheeses such as cheddar, Gouda, and brie. These bacteria contribute to a mild, creamy texture and are best suited for cheeses that do not require high heat during production. On the other hand, thermophilic bacteria, which can withstand higher temperatures, are essential for cheeses like Swiss and Parmesan. These bacteria contribute to the development of complex flavors and, in the case of Swiss cheese, create its signature holes, or eyes, by producing carbon dioxide gas during fermentation. The fermentation stage sets the foundation for the cheese's unique taste and consistency. It typically lasts from a few minutes to several hours, depending on the type of cheese being made. During this time, the milk thickens, becoming more structured, which prepares it for the next critical step. Coagulation. Coagulation is the process of transforming liquid milk into solid curds, a defining stage in cheese production. This is achieved by adding an enzyme called rennet, which causes the milk proteins, primarily casein, to bond together and form a gel-like structure. Traditional rennet is derived from the stomach lining of young calves, but modern cheesemaking also offers microbial and plant-based alternatives, making it possible to produce vegetarian-friendly cheeses. There are different methods of coagulation, each influencing the texture and characteristics of the final cheese. Enzymatic coagulation, which uses rennet, is the most common method and is used for hard and semi-hard cheeses such as cheddar, Swiss, and Gouda. This process results in a firm curd structure that retains its shape during aging. Some cheeses, such as ricotta and paneer, rely on acid coagulation. In this method, an acid like lemon juice or vinegar is added to the milk, causing it to curdle naturally. Acid coagulated cheeses tend to have a softer, more crumbly texture and are often consumed fresh rather than aged. Another technique, known as heat and acid coagulation, is used for cheeses like mascarpone and cream cheese. In this process, the milk is heated before an acid is introduced, allowing the proteins to coagulate more gently. This method produces soft, spreadable cheeses with a rich, creamy consistency. Regardless of the coagulation method used, this stage is crucial in defining the cheese's final texture. Once the milk is fully coagulated, it forms a large, custard-like mass. This solidified milk is then carefully cut into smaller curds, which marks the beginning of the next phase in cheese production, separating the curds from the whey, cutting, cooking, and draining the curds. Once the milk has coagulated into a solid mass, the next step in cheese making is cutting the curds. Specialized stainless steel blades are used to slice the curds into smaller pieces, and the size of these curds directly affects the cheese's final texture and moisture content. Larger curds retain more moisture, leading to soft, creamy cheeses like brie, while smaller curds release more whey, resulting in firmer cheeses such as Parmesan. The cutting process is carefully controlled to ensure consistency across batches. After cutting, the curds are gently heated in a process known as cooking. Heating helps expel additional whey and influences the texture and flavor of the cheese. Stirring during this phase ensures that the curds are evenly exposed to heat, allowing for uniform moisture loss. Different cheeses require varying levels of heat. Milder heating produces softer cheeses, while higher temperatures create firmer varieties. This step is essential in determining the cheese's final consistency and structure. Once the curds have reached the desired firmness, the whey is drained. However, whey is not wasted. It is a valuable byproduct in the dairy industry. Factories repurpose whey for a variety of products, including whey protein powder, ricotta cheese, and even eco-friendly bioplastics. By utilizing whey efficiently, cheese production becomes more sustainable, reducing waste and maximizing resources. Pressing and molding the cheese. After the whey is drained, the curds are transferred into molds that define the cheese's final shape. Pressing is then applied to remove any remaining liquid and compact the curds into a solid form. The level of pressure used varies depending on the type of cheese being produced. Soft cheeses, such as feta, require minimal pressing, allowing them to maintain a delicate, crumbly texture. Salting, enhancing flavor and preservation. Salting is an essential step in cheese production, serving multiple purposes beyond just enhancing flavor. It plays a crucial role in preserving the cheese, controlling moisture levels, and preventing the growth of harmful bacteria. The method and duration of salting significantly impact the cheese's taste, texture, and overall quality. There are two primary methods of salting: dry salting and brining. In dry salting, salt is manually rubbed onto the cheese's surface, which is common for cheeses like feta and blue cheese. This method allows for gradual absorption, influencing both the rind formation and internal flavor. On the other hand, brining involves submerging the cheese in a saltwater solution, ensuring even salt distribution throughout the cheese. This method is widely used for cheeses like mozzarella and Swiss, where uniform salt absorption is essential for proper aging and texture. The amount of time cheese spends in brine affects its firmness and salt content. Aging and ripening, developing flavor and texture. Aging, or affinage, is the process where cheese is stored in controlled environments to develop its distinct characteristics. The aging period can range from a few weeks to several years, depending on the type of cheese. Temperature and humidity are carefully regulated in aging rooms to facilitate bacterial and mold growth, which contribute to flavor development. Packaging and distribution. Once the cheese has reached its ideal maturity, it is cut, packaged, and prepared for distribution. Factories use advanced packaging techniques to preserve freshness, prevent contamination, and extend shelf life. Common packaging methods include vacuum sealing, waxing, and modified atmosphere packaging, all of which ensure the cheese reaches consumers in peak condition. Cheese making is a remarkable fusion of age-old tradition and modern science. From fresh milk to aged perfection, each step in the process contributes to the diverse range of cheeses available today. Factories have revolutionized cheese production, ensuring efficiency, quality, and accessibility while preserving the artistry of this ancient craft. And that's the incredible journey of how cheese is made, from fresh milk to the delicious varieties we enjoy every day. It's a perfect blend of science, tradition, and craftsmanship that brings unique flavors to our tables. What's your favorite type of cheese? Let us know in the comments. If you enjoyed this deep dive, don't forget to like, subscribe, and hit the bell icon for more amazing food journeys. Thanks for watching, and we'll see you in the next video.